These are the lecture notes for Chapter 2. This is the chapter on chemistry, the basic chemistry, the chemical foundation of life. Okay, here we go. Um, so this chapter is basic chemistry. We also have another chapter, Chapter 3, which focuses on the chemistry of specifically living things. But you have to have a little bit of background. So that's what this is. Um, you've probably heard most of this information before in other science classes, but this slide is just talking about atoms. Atoms are the simplest particles of, or the smallest particles of an element, and you may have seen elements on the periodic table of elements. Um, so atoms are the building blocks of molecules. Molecules are just combinations of two or more atoms that are chemically combined. We know that living things are composed of matter. Non-living things are also composed of matter. Matter is just simply anything. I'm not trying to do a figure eight, but it's sometimes I just don't write very well. You've probably noticed. But matter is anything that occupies space. In other words, it has a volume and has a mass. Sometimes we say weight, but it takes up space and it has a mass. So that could be anything from solids, liquids, gases, and there are actually some other forms of matter called plasma, but in biology, we just stick with solids, liquids, and gases. Um, Elements are forms of matter they're the simplest forms of matter. So each element has a specific chemical property and specific physical properties. Elements can't be broken down into smaller substances. So another way to say that is that elements are the simplest forms of matter. Each element has its own chemical symbol, either one or two letters. Sulfur has the chemical symbol S. In biology, we're going to find sulfur in proteins. Proteins contain a lot of sulfur. And calcium has the symbol Ca. The first letter is always capitalized, but if it's got two letters in it, the second letter is lowercase. The four most common elements in living organisms are carbon, which has the symbol C, oxygen, which is O, hydrogen H, and nitrogen N. You also will have sulfur, which is found in proteins, and then phosphorus. I'm going to add phosphorus because phosphorus is an important component of DNA. So phosphorus has the symbol of P. If you've had any science classes before, you may have heard the acronym CHNOPS. So I'm going to write that down for you also. Sometimes that can be helpful in helping you to remember the six most common elements in living things. Here, your first four, we already went over: carbon, hydrogen, nitrogen, oxygen, and then you've also got phosphorus and sulfur. So those are the six most common elements found in living things. And this table shows you the percentages. Obviously, oxygen by far is the highest percentage. So that's the element with the highest percentage in living things. Um, let's see. So the definition of an atom is that it's the smallest unit of matter, or it's the smallest unit of an element that retains all the chemical properties of that element. So it's just the very smallest particle that you can find of an element. But there are smaller particles than atoms. Atoms contain particles within the atom called subatomic particles. So those are protons and neutrons, which are found in the center of the atom called the nucleus. And I'm going to go ahead and warn you, give you a heads up now. There is a nucleus found in the center of an atom, and that's what the center of the atom is called, the nucleus. But in biology, when we learn about cells, we're going to learn about a cell part or an organelle called a nucleus, and that is a totally different thing. It's not the same thing. It's the nucleus of a cell, for one thing, is many, many, many more times larger than the nucleus of an atom. The nucleus of an atom is simply the center. The nucleus of a cell is actually a particle. It's a little organ or an organelle that contains the DNA. So it's just a totally different thing. You have to be very careful when we talk about a nucleus of an atom versus the nucleus of a cell. But for this chapter, the nucleus just refers to the center of the atom. It's just referring to the region in the very center of the atom. And so protons and neutrons are subatomic particles that reside in the center of the atom, and electrons reside outside of the nucleus. And what you need to know about each of the subatomic particles is their charge, their mass, and their location. And I really don't care that much about the mass, except I just want you to realize that the protons and the neutrons have the same mass, and an electron is practically zero compared to the mass of a proton and a neutron. In other words, the electron has the smallest mass, and it's practically weightless. Electrons are very, very small particles. So protons have a charge of +1. Neutrons have a neutral charge or zero charge, and electrons have a -1 charge. The proton is located in the nucleus along with neutrons, and then electrons reside in orbitals, or sometimes we call them electron shells. And they can also be referred to as energy levels. In fact, I tend to refer to them as energy levels. So, but basically, if you just remember, electrons reside outside of the nucleus. And this is an example, a model, an illustration of a helium atom, symbol He, which contains 2 protons. We know these are protons because they have a positive charge and they're located inside of the nucleus. And then 2 neutrons, which have no charge, a neutral charge, and they are also located inside the nucleus. So we have 4 total subatomic particles located inside of the nucleus. And then we have 2 electrons located in the first energy level, or the first electron shell, or orbital. And here are those 2 electrons. So 2 protons, 2 neutrons, and 2 electrons. So there are also some numbers that you need to know. The atomic number of an atom is the number of protons. So if the atomic number is the number of protons, then the atomic number for helium is 2. And then the mass number is the number of protons plus neutrons. So if the mass number is the number of protons plus neutrons, then the mass number for helium is 4. And here we have those definitions again. The atomic number is equal to the number of protons. In fact, the number of protons actually defines the atom. So if the atom has 2 protons, it's always helium. Helium will never have a different number of protons. If an atom has 6 protons, then it's always carbon. So the atomic number is actually what defines the atom. Each element or each atom of an element has a distinct atomic number, a distinct number of protons. The number of neutrons and the number of electrons in an atom can actually change. So, and it can still be that same atom, but the number of protons will never change for an atom. The atomic mass, also referred to as the mass number, is the mass of the atom, but if you average that atomic mass, then you get a number that is equal to the number of protons and neutrons. So technically, the number of protons plus neutrons is the mass number. The atomic mass is an average of the mass numbers of all of the different isotopes of an element. So that brings us to another definition. So if all elements have, if an element has a certain number of protons, and that number can never change, it can have different numbers of neutrons. So you can have, for example, we'll use carbon. You can have carbon, an isotope that contains 6 neutrons, and you can have, and that's carbon 12. And then you can have carbon 13, which has 7 neutrons, and carbon 14, which has 8 neutrons, but it's still carbon. And all atoms of carbon have 6 protons. So the atomic mass is the average of the masses of all the different isotopes, the different forms of that atom that have different numbers of neutrons. But basically, if you round the atomic mass to the nearest whole number, the mass number is the number of protons plus neutrons. So you go into that a little bit more in chemistry class, and we just kind of skip over it very quickly in biology. So this is an illustration of the 2 isotopes of carbon. There's actually a third isotope, carbon 14, that I'm going to draw in here so you can see all 3 of them. And the mass number of carbon 12 is 12, and carbon 13 is 13, and carbon 14, the mass number is 14. So we know the atomic number 6 is the number of protons. If we would like to know the number of neutrons for each of these isotopes, then we have to subtract the mass number from, subtract the atomic number from the mass number. So if we say 12 subtract 6, we get 6, and that means there are 6 neutrons in carbon 12. And if we do 13 subtract 6, we get 7. So there are 7 neutrons in carbon 13. And you've probably already done the math. 14 subtract 6 gives you 8 neutrons for carbon 14. So they're all the same element. They're just different isotopes of that element. Here's another example of isotopes. Again, isotopes are forms of an element with different numbers of neutrons. And if they have different numbers of neutrons, then they're going to have different mass numbers, because the mass number is the number of protons plus neutrons. So here we have protium, which is hydrogen 1, and hydrogen 1 has a proton and it has an electron. Proton with a positive charge and an electron with a negative charge, and it has 0 neutrons. Deuterium, or hydrogen 2, has a proton, a neutron, and an electron.